Hi there, welcome to this lesson on solving logarithmic equations algebraically. We're going to go ahead and build on knowledge from the beginning of this unit about using properties to simplify logarithms to help us solve some logarithmic equations. Now, just a refresher on using properties to solve logarithmic expressions as seen here. Generally, the first property that you're going to use is the power property. And just a reminder that you can go ahead and take a coefficient, as seen here, the 2, and I can go ahead and I can rewrite this logarithm as log base 6 as 3 squared. I just bring this coefficient up into the numerator, and I use it as a power for the argument. So we have log base 6 of 4 plus log base 6 of 9. And now what we're going to go ahead and do, generally the next step is to use a quotient or a product property. And in this case, we are adding. So we're going to go ahead and use the product property, which says if I have two logarithms of the same base, I can rewrite them as one logarithm, and since we are adding, we multiply the arguments. Okay, so 4 times 9, that is 36. I have log base 6 of 36, and then here I'm going to go ahead and use an identity property, which just says that if I have a logarithm where the argument is the same base, I'll just say m here, I can go ahead and cancel these, and the answer is just the exponent. So I'm going to rewrite 36 as log base 6 of 6 squared, and then the exponential base and the logarithmic base cancel to give us 2. So we're going to be doing some of that today when we go ahead and solve these equations. All right, so here is a refresher on the properties. Again, like I said, the main properties that we will be using are the power property. You can go ahead and bring your coefficient up into the power. We'll also be looking at the product property and the quotient property, and that just says if we add, we multiply, and if we're subtracting two logarithms, we are dividing. Other properties that we'll use in the second video on this lesson are the exponential form. I can go ahead and rewrite a logarithm as an exponential. And then some property of equality that we're definitely going to be using is that if I have a log base b of x and it's equal to log base b of y, then x is equal to y. We essentially, you can think of it this way, as canceling the two logarithms. Here are the steps that we're going to use to solve logarithmic equations when we have logarithms on both sides. The first thing that we're going to use is we're going to use the properties of logarithms to write the equation with a single logarithm on each side, and that's the important part, single logarithm of each side. Make sure you underline, highlight, circle that part. Step 2, we're going to use the property of equality for logarithms to set the arguments equal. And here's, again, the main idea. If I have a logarithm of the same base on each side, I can cancel them to make the arguments equal to each other. Okay, it's just a way to get rid of the logarithms. Step 3, solve using algebra. We'll go ahead and do that. And then lastly, we have to check for extraneous solutions. How do we do that? Well, the argument of a logarithm must be positive. So when we get our logarithm and we go ahead and plug it in and check, if it changes any of the arguments to 0 or negative, we have to throw that answer out. Here's the first example, and we want to solve this equation. I'm going to remind you that step 1, you want a single logarithm on each side. Single log on each side, and we're going to use properties to go ahead and condense this. So on the left side, I have 2 natural log of x, and on the right side, I have 6 times natural log of 2. Well, I'm going to go ahead and use the power property here. I'm going to go ahead and bring that up. So I have the natural log of 2 to the power of 6 minus, and again, I'm going to use the power property. I'm going to go ahead and bring that up. So this becomes the natural log of 2 to the power of 4. Okay, and I can do some simplification here. We have the natural log of 2 to the 6. If you don't know 2 to the 6, just work your way up. I mean, 2 is the easy one to check. So 2 to the 4th is 16. 2 to the 5th is 32. So 2 to the 6th is 64. So natural log of 64 minus the natural log of 16. And now I'm going to go ahead and use the quotient property. I guess I should write these down. Maybe they're generally the same order. So you have your power property, and then here, secondly, we're going to use the quotient property. We did this first, we're doing this second. So I'm going to go ahead and condense these into a single logarithm. So we have the natural log of 64 over 16. Okay? And I'll go ahead and divide those, which gives us 4. So I have, well, I guess here too, I could use the power property if I didn't see this side. Bring up that 2. So we have natural log of x squared. So there are, that's the condensing of logarithmic equations to where I have a single logarithm on each side. Notice, I have 1 logarithm on each side. Step 2. Use the property of equality for logarithms, which just essentially says I can remove my logarithms. Okay? So this gives us x squared is equal to 4. Step 3, we're going to go ahead and solve this. This is rather simple algebra, getting rid of a square root, so I'm going to take the square root of each side. So plus or minus 2. Plus or minus 2. Now I have 2 solutions here. I have x equals positive 2 and I have x equals negative 2. At this point, this is where we have to check and see, okay, is this solution extraneous or not? And we're going to go ahead and check it using our original equation up here. So I'm going to go ahead and I'm going to plug in 2, x equals 2 into here. Does it make it positive? Well, yes, 2 is a positive number. So this argument right here, this is all I care about. Does this remain positive? And I know there's not a lot happening here. It's just a number, like we're plugging in our answer. Sometimes the arguments are you know, a little bit more complex, and by a little bit, I mean a little bit. You know, do they stay positive? In this case, yes, it does for 2. So 2 is an answer. This is valid. And I like to write valid, that way I know I'm checking. Negative 2. If I plug in negative 2 here, x equals negative 2. If I plug that in, hey, my argument's negative. It's a negative number. So this answer is extraneous. We're going to throw it out. Ignore it. X equals 2 is the only answer. Here's a second example. We have log base 2 of x squared minus 2 is equal to log base 2 of 10. So I want to go ahead and solve this. Note step 1, having a single logarithm on each side is already done. It's already done. I have log base 2 of x squared minus 2 equals log base 2 of 10. So I can go straight to step 2, which is the exponential, or sorry, not exponential, it's the logarithmic property of equality, which just says, hey, I can cancel these. So we get x squared minus 2 is equal to 10. Okay, now I want to go ahead and solve. So I'm going to add 2 to both sides. We get x squared is equal to 12. Now I'm going to take a square root of each side. So we get x is equal to plus or minus square root of 12. And 12 can be rewritten as 4 times 3. So our solution is plus or minus 2 root 3. Okay? All right, I got to check. Step 4, make sure you check. So if I plug in the positive 2 root 3 here, if I plug this in, it gives me a 12. 12 minus 2. That's 10. 10. Is that positive? Yes. So x equals 2 root 3. That's an answer. What about negative 2 root 3? X equals negative 2 root 3. Well, if I plug it in, negative 2 root 3 squared, that becomes positive, right? Because a negative times a negative is a positive. So I still end up with 12 minus 2. Okay, so the negative answer is also an answer. X equals negative 2 root 3. That's also a solution. There you go. And you can leave it as plus or minus. I'm okay with that notation as well. Here is a practice problem. Please go ahead, pause the video, and try this one. Remember your steps. Step 1, write it as a single logarithm on each side. Don't get freaked out. This one is a little bit different, but give it a go. Okay, hopefully you pause the video. I'm going to try to reveal it in steps. You can write it as a single logarithm on each side. So you have natural log of 80 over x squared equals natural log of 2. Now I can use the property of equality to get rid of my logarithms. So I have 80 over x squared equals 2. A lot of people freak out at this stage. They say, hey, I have my variable in the denominator. This doesn't look right. Am I doing this wrong? It's okay. How do you pull something out of a denominator? Or how do you clear a denominator? Well, what's the inverse of division? Multiply. I just multiply each side by x squared. So we get 2x squared equals 80. You can pause this and try the rest of this if you want. So we get x equals the square root of 40 plus or minus. And then simplifying root 40 is 2 root 10. So there's that one. That one's a little bit different. Okay. All right, next example. All right, so I have a lot going on in this example. What I'm going to go ahead and do first is, in order to write it as a single logarithm, remember that's step 1, single log. I'm going to use my properties. My screen keeps glitching. I don't know if you guys are seeing this on your end. That's kind of weird. Okay, so this becomes log base 6 of 2 squared, which is 4. And let me go ahead and rewrite this. So log base 6 of, and here I'm going to go ahead and use the product property. So I had 2 squared, that's 4. I hope you guys are okay with that. And then I have this x here. So there you go. So that's 4x on this side. I multiply, right? Because I'm adding. And then over here on the left, I'm adding, right? Adding. So I multiply too. So this is log base 6 of x plus 4 times x minus 2. Single logarithm on both sides. So before I go ahead and multiply out the argument on the left side, I'm going to do step 2, which is the property of equality. I'm going to get rid of those. So now I have x plus 4 times x minus 2, which is equal to 4x. Okay? All right, here's where we do step 3, good old algebra to solve. So I'm going to go ahead and multiply this out. X times x gives me x squared. X times negative 2, negative 2x. We get a positive 4x. I can combine those. And then lastly, 4 and negative 2 is negative 8. So let me go ahead and clean this up. We get x squared plus 2x minus 8 is equal to 0. Okay, right on. Cool. I now have, oh wait, not 0. Getting ahead of myself. 4x. So I have a quadratic. Now I want to go ahead and solve this. Remember, I need to set one side equal to 0. So I'll subtract 4x. And we get x squared minus 2x minus 8 is equal to 0. I'll go ahead and factor. So x minus 4, x plus 2. And we're going to, looks like, have two possible solutions. X minus 4 is equal to 0, or x plus 2 is equal to 0. So I'll add 4 to both sides. And this gives us x equals 4. And I'll subtract 2 on each side, which gives us x equals negative 2. So here's our possible solutions. And I got to go ahead and check. So remember, I'm going to plug this into my original equation up here. So I have 4 plus 4, that's 8. 4 minus 2, that's 2. 4 plugged in there gives me 4. All of that's positive, so this is valid. I'm going to keep it. Let's play the game again, but this time with negative 2. Negative 2 plus 4, positive 2. We're good. Negative 2, take away 2. Ah, that's negative 4. It's negative. Got to throw it out. Extraneous. Okay, and 2, if I plugged in negative 2 right here, whoop, it's negative. So we throw it away. Okay? Ask yourself, how did I know, why did I throw out negative 2 as an extraneous solution? That's an essential question. Why is negative 2 extraneous? Okay. Here's a practice problem. Please go ahead, pause the video, give this one a try. All right. Hopefully you gave this one a try. On this one, you just have to go ahead and add. So you're adding the logarithms on the left side, so you multiply them. And go ahead and use the property of equality for the logarithms to cancel out the logarithm. And you get two solutions, 3 and negative 1. Both are extraneous. Well, why? If I plug it into this x minus 3 right here, 3 minus 3 is 0. Remember, it must be positive. It's got to keep the argument positive. Okay? So no solution on that example. All right, next example. Here, note, I don't have any coefficients out front, so I don't have to use the power property, but I am subtracting, so I'm going to use the quotient property for logarithms. So this becomes log base 3 of 2x over x minus 3. Step 2, property of equality. I can just get rid of my log base 3. So I have 2x over x minus 3, which is equal to 5. Okay, well, how do I get rid of a denominator? I multiply. So x minus 3, over here these cancel, and we have 2x is equal to 5x minus 15. All right, I want to go ahead and solve this linear equation, so I'm just going to subtract 5x on each side. And we get negative 3x is equal to negative 15. We'll divide by negative 3, and we get x is equal to 5. Okay, so I can go ahead and check. If I plug in 5 here, 5 minus 3, that's a positive 2. If I plug in a 5 here, 2 times 5 is 10. We are positive. So that's our solution. All right, here is a practice problem. Please pause the video. Give this one a try. Okay, hopefully you pause the video. You got to use the power property and then the quotient property to get natural log of 16 over x is equal to natural log of 64. We'll multiply both sides by x to give 64x is equal to 16. And then we divide to get x is equal to 1/4. Did you get it? Good job. All right. Here is another practice problem. Please pause video, try this one. Okay, hopefully you paused it. In this case, we get x equals 6. We're going to go ahead and throw out the -4. Okay. All right, so that's going to do it for this video. I'll catch you next time. Be safe, be easy. Peace.